Okay, guys, we're moving on.
Volume.
Volume. And I like volume.
Me too. One of my
Volume's fun.
favorites. Yeah.
Just talking about how much space is within a three-dimensional shape. And so really we've just been talking about surface area with these kind of shapes. And so now we're talking about the inside of that. And you can kind of think about it as the classroom, how much air is inside the room. If you look at car advertisements or whatever, you'll see that they'll talk about how much cubic feet space is in a particular van or SUV or whatever for storage space and so on. Lots of examples out there.
Yep.
So we're talking about the space inside of a three-dimensional shape now. And we step it up one. That now we're measuring things in cubic units. So cubic feet, cubic inches, cubic miles, cubic centimeters, whatever it might be. And so in this first section of volume, we're talking about the volume of prisms, which again is just kind of a fancy term for a box of some shape. So volume of a prism and volume of a cylinder. Is that the other shape that we're doing?
Yes.
Yeah. So cubic volume is basically if you were asked to find the volume of a cube itself, which remember what a cube is, it's the same dimension on all three sides, kind of like a three-dimensional square. It's a cube. And so you would just take the side length and cube that side length because all three of them are the same. Now that's based on the fact that when you find the volume of a box, a rectangular box, it's length times width times height. And so for a cube, all three of those are the same, and so it's just S cubed.
Yep.
This compares to area as well. We talked about, what did you call them? Compound shapes?
Compound shapes.
Compound shapes where we add up the different areas to get the odd shaped things. Same thing with volume. If you have some weird shaped box like this that has a chunk out of it or pieces added to it or whatever, then the volume addition postulate says that the total volume of that whole thing is the sum of all of its parts. Now for this particular one, you could actually kind of do it backwards. You could find the volume if that box was whole, find the volume of the piece missing, and subtract it. Same concept.
Yep.
And so, so they're asking us to find the volume of this box down here. And you have to be careful here how you split that up sometimes.
Yep, you do.
If you split it one way, it would be very difficult to find it, and if you split it another way, it makes it pretty easy. So you kind of have to see how they break up the box in order to do that. And so as I'm looking at this, I'm looking at if you were to try to like cut off, like it looks like a box is on top of another box, and then on the right side it's another box on top of the box. If you try to split that, we really can't do that here because we don't know what the height of that top piece is. We only know that the height of the whole thing is 2. It'd be making an assumption that it's split in half, but I don't think it shows that. I don't even know if that we could look at maybe if you look at that kind of graph paper that's in there, it kind of shows that would be 1. But maybe it would be better if we just dropped them straight down and figured it out that way instead, to where it's a box on the left, box on the right, and then a short box in between them in the middle. And again, you could do this multiple ways. I'm just saying if we didn't know that grid pattern was in there, we wouldn't know how tall the bottom box is because of the way they give us the units here. So you could do it a couple different ways. Let's just do it the way that I was talking about there. And so if we do that, then if we look at the box on the left, it's 2 units tall, it's 2 units wide, and if you look at it, it's 2 units deep as well, okay, because the 2 units on the right side transfers over. So it's a 2 by 2 by 2 cube. So it's 2 cubed, or 2 times 2 times 2, which is 8. So the volume of that is 8 cubic units. If we look at the box on the right, it is 2 units tall, 1 unit wide, and 2 units deep or long here, okay? And so that one's 2 by 2 by 1, and so 2 times 2 is 4, times 1 is 4, so there's 4 cubic boxes, 4 cubic units inside that box. Then if we find the box in the middle here, well, it's not 7 units long anymore, okay? It would have to be, the whole thing is 7 units long, but we'd have to subtract 2 from the left side, 1 from the right side, so that box in the middle is actually 4 units long, okay? Well, I guess we'd be in the same predicament though, wouldn't we?
Yeah.
So either way you do this one, you still don't know for sure the height of that, other than that kind of grid system they put in there. So either way, we're going to have to make an assumption that that bottom box is 1 unit tall. And so it's 4 units wide, 1 unit tall, and still 2 units deep. And so it'd be 7 times 2 is 14, times 1 again is just 14. And so we had 8 on the left, 14 in the middle and 4 on the right. And so as you add those units up, we would end up with, what would that be, 22 and what would we say, 4?
8,
so 26?
12, yep.
Is that right? 8,
12 and 14.
8, 14.
14. So 12 and 14 is 26. You're right.
No, is that what we had in the middle? No, what did we have in the middle? We had,
7 by 2 by 1?
no, 4 by 2
Full,
by 1. 8. Did I say 7? Maybe I said 7 earlier, sorry. So it's 4 by 2 by 1. So it's 8 units in the middle. So it's actually 8 and 8 and 4? Is that right?
Yep.
Okay.
That's right. 8 and 8.
Is that right? 8 and 8 and 4?
16
So
plus
20,
4,
20 cubic
Yep.
units. So again, we're adding the cubic units that we're talking about here for that volume addition postulate. Okay. And maybe you would think that it would be easier to cut the boxes off the tops and find them that way. You could do that too, as long as you know that that height is 1. And so you could do this either way. Okay, but there will be some that it
Yeah.
would be difficult one way compared to the other.
Right.
So either way you want to do that one. All right?
All right. 12.6 is the volume of these prisms now, and we have to be able to just kind of look at these shapes. And, you know, Mr. Scritchfield and I have been after you guys in chapter 11 back then to be able to figure out the areas of these certain shapes and be able to look at these shapes to figure out what they are. And this is going to be really important again here with volume, you guys. And so, you know, the base formula for volume is V equals the area of the base times the height between the bases. Now, this is really, really important that you get this, especially when you look at this first example here on the right, because there's 2 heights in there. There's the height of the trapezoid on the base, but then there's the height of the actual prism, and you got to be able to know that h in the basic formula is the height between the bases. So when you see this, you know, just understand that h in the basic formula is in between the bases, and then that big B is going to always change depending on what the shape of the base actually is. So in this case, okay, we're looking at a trapezoidal prism here. Okay, and we want to find the volume of that. Well, since the bases are a trapezoid, we have to change that big B into 1/2 the height times the average of the bases. And so your formula adjusts from volume equals the area of the base times the height to the volume equals, okay, well, we change the base to 1/2 the height and then the average of the bases there to give us just the base of the prism. And then we're going to multiply that to the height of the whole prism, which in this case is going to be 5. So let me go through the numbers and where they're getting them from. 1/2 is in the formula, okay, because 1/2 the height times base 1 plus base 2. 3 is the height of the base shape, okay, the base shape, the trapezoid. 14 is the area or the length across the back end of the base. 6 is the length of the area in the front of the base. Now, just transfer that 6 up, guys, visually, and you'll see that it's the same 6 in either the top or the bottom of the prism. And then that 5 comes from the height between the trapezoid on the top and the trapezoid on the bottom. It's that perpendicular height between the bases. And then all you got to do is, you know, multiply things out, cut things in half, and you get that the volume is 150 centimeters cubed. Really the hardest thing I see students do, they don't necessarily have a hard time remembering what the height is between the prisms. It's taking out that big B and putting in the right formula in there, especially when we get to like a hexagonal prism and stuff like that, and changing that B to an AP.
So, Mr. Villa, could I have just taken this one and kind of like flipped it on its back and taken the rectangle to be the base instead? Couldn't I just do it that way and make the 3 the height of the prism?
No, because we want to have 2 of the exact same shapes for our base. Remember, guys, it's basically the height between the 2 congruent shapes that are parallel to one another. And so that's what we usually do. So that's a great question that Mr. Scritchfield asked me, because it would seem, oh, I know the area of a rectangle real easy, and it's a rectangle on the bottom and a rectangle on the top. However, okay, we're looking for those 2 congruent pieces that are parallel to one another.
The base has to be 2 bases that are parallel to each other and exactly congruent to each other.
Yeah.
So you got to look for that in the shape to figure out what the base is, because sometimes they'll draw them not sitting on the base.
That's
like
right.
This one,
Like
they
this
might
one.
draw
Right.
it to where it's sitting on that rectangular, like flipped over on that side, but that's not the base.
Right.
Just because it's sitting on that doesn't mean it's the base.
So be real careful that that's an important thing that Mr. Scritchfield points out, and that's another area where I see kids make some mistakes.
Yeah.
Especially with the triangular ones. Holy moly.
Oh, yeah.
So.
Yeah. Okay, so those are prisms.
Prisms.
V equals capital B, which is the area of the base. V equals area of the base times the height. Pretty basic formula. It's just that that capital B changes depending on what the shape of the base is.
Yep.
So that's where chapter 11 comes in. So let's go to volume of a cylinder. Basically the same thing.
Yep.
It really is the same formula.
Yep.
Volume equals base times height.
Yep.
Area of the base times the height. It's just that the base is a circle.
So we just can always think of it as pi r squared.
So we're switching, instead of switching the B in the last one to 1/2 height times to the two bases added together, it's pi r squared because that's what the base shape is here. It's a circle.
Cylinders are the easiest ones.
Oh, yeah. Yeah. Other than they come out in pies, and that throws some people, but you just got to remember that from last chapter that we, just as it says here, leave it in terms of pi. And so we switch out the B for pi r squared because that's the area of the base, and so we just find the area of this circle. And you can kind of think about this stacking up little discs that are that shape. We have 6 of them in this case because it's 6 feet tall.
Yeah, you just
And
take
so
up
if we
6
had
fours.
6 discs, 6 circles on top of each other, find the area of one of them and multiply it by 6 of them, and that's the volume of the cylinder here. So we have a circle with radius of 9, and so when we plug that into our formula from up above, we're going to have an 81 pi basically times that height, 6, and so we're just going to multiply that out. They want it in terms of pi, and so it just comes out to 486 pi, 6 times 81, cubic feet. Now again, it's volume, and so it's always measured in cubic dimensions because we squared the radius, so that's 9 feet times 9 feet, 81 square feet, because we multiplied feet by feet. Then we multiplied by another foot in the 6 feet height, and so that's where the cubic feet comes from. All right, so cylinders are easier in a way. They're just circles, so you got to deal with circles is all. So we'll do more examples in class.
Yep.
But basically, boxes and cylinders are what we're trying to find the volume of here to begin with volume, and they get a little bit more complicated, but not too much.
No,
So.
they're good stuff.
Okay, so we'll do more examples in class, guys. We'll see you there.